So in this video what I'm going to do is have a look at the Sonoff SC environmental sensor. This is another product from IT Studios. I am a big fan of their kit. The Sonoff range is all based on the ESP8266 microcontroller, which is a brilliant device, which is a microcontroller with a Wi-Fi device all built into one chip. The beauty of it is that it has an easy to program interface and is very well supported, and in fact any fans of the Arduino microcontrollers, the ESP8266 can be programmed using the Arduino environment, and the Arduino is kind of version of C++, its programming language. We're not going to do any programming of the device today, but what we're going to do is have a look at the internals of the machine and apply a few modifications to the machine as well. We'll worry about how we program those modifications and get the machine working with them at a later date. So I've had a chance to have a look around this machine, but I thought I'd start with it completely assembled, just so that you could see in the video how this thing is, how this thing's taken apart, and what steps we're going to take to get it ready for modification and program it. So first things first, the device itself, it's you can see just inside there perhaps that there's some sensors in the middle of the machine there. It's in a white plastic case. My hope is that this case will be translucent. It does seem to be, there's an LED in here which does seem to shine through the case, but my hope is that the rest of the case will also be translucent. The reason why I want it to be translucent is that I'm planning to add addressable LEDs, and hopefully I'm going to be able to turn this not only into an environmental sensor but also into a super fancy nightlight that will change colour perhaps, or even at a later date I might be able to control it from my home automation and have it flash different colours for different types of alert. So without further ado, I'm going to get the thing open. To open it, we just go to the base of the machine. There are 4 screws, that is all that it takes to get the thing open. So I'll just get these undone. And there we go, the bottom should just come off of this, which it does. And what we can see is the PCB which controls everything. So on this PCB, it's a big circuit board with actually not a lot on it. What we have over here is the ESP8266, and you can just see on the PCB it has its antenna is a PCB antenna. It has its own programming header, and in a moment or two we're going to add some pins to that so that we can control it. To program the ESP8266 we use a basic serial connection with a serial programmer. So what we've got here is 3.3 volts, TX, RX, ground and SDA. The SDA pin seems to be a spare one, so perhaps later on if we want to do something we can use that pin for connecting another sensor, or I'm not entirely sure what I'm going to use it for, but it's there and it really is just screaming to be used. Over here we have a 3.3 volt voltage regulator. So the Sonoff takes a 5 volt USB connection here, so you can connect it to an old mobile phone charger or whatever to keep it powered. It has a button here which allows you to kind of put it into programming mode so that you can give it a Wi-Fi instructions, or you can talk to it with IT's own app. And it also has a micro SD slot, which as it's sold from IT, although the hardware is there for the micro SD, and it is there for the SD, and it's plugged in as well, their own firmware doesn't actually do anything with it. So it looks like they popped it in place there, perhaps because this case was probably repurposed. It certainly looks like it was meant to be for a Bluetooth speaker, and this was possibly so that they could play, you could play tunes using a micro SD slot, but instead they've used it for the Sonoff device instead. Yeah, there'll be a couple of things that kind of make that obvious when we look at the device itself. So they've popped it on there. They aren't using it yet, but it's not to say we couldn't use it in future. Here we have two jumper pins. IT have always been very keen that people hack their products, and they've made it as easy as possible. One, they've supplied programming headers for the microcontrollers that are on board this, but also these microcontrollers talk to each other, and this allows you to break that link when you're programming. Which brings me across to this device over here. Over here what we've got is an APP 328 microcontroller. The number of sensors that this device has, it's got a microphone sensor, it's got an air quality sensor, a light sensor, and a temperature sensor on it. I don't think they could get everything to run just off the ESP8266. So what they've done is they've added the APP, which if you're familiar with Arduinos, this is the same chip as you find on the Arduino Uno. And basically it talks by serial to the ESP8266, which works as a Wi-Fi bridge to allow this device to talk to IT's own servers. So we're going to be working mostly with the Arduino side just now. I'll worry about this ESP8266 afterwards. So you can see what's on the board here. The microphone here is just connected to some sort of op-amp, and then to one of the analog ports on the APP. So what I'm going to do now is I'm just going to remove this PCB and the sensors from the case, and we'll do this with these larger silver screws. We'll just pop them out, pop them to the side. Now this is a little bit of a fiddle to get out, because what you've got, well, you'll see in a moment or two, there's a little button here which is going to try and prevent it coming out, so we have to kind of tilt it sideways, and it feels like you're giving it a little bit of force, which worries me slightly. I certainly wouldn't want to be doing this too many times, and then eventually out it pops. So you can see here the inside of the Sonoff device here. This is the flip side of the PCB. We have this tower here which contains this dust sensor. This here is a DHT11 temperature and humidity sensor, and then all we've got here is a light dependent resistor. These plug into the board with some headers here, and one of the things that I'm going to change on this is this sensor here. The DHT11 is not the very best sensor that you can get for temperature and humidity. It's got pretty low resolution and it's reckoned not to be especially accurate. So I'm going to remove that from the assembly here, and I'm going to replace it with a DHT11. These are pin compatible, so okay, the IT firmware isn't going to work with this device, but we're going to change the firmware over eventually anyway. So that's the first one of the things that I'm going to change, and we'll just try our best to get this off now. It's hot glued on, that's all. And hopefully this hot glue is going to come off without too much fuss. So I've gained a DHT11 for my parts bin, and I'm now going to plug in and hot glue in this device here, which is an AM2302, or better known as the DHT22. So I'm just going to plug that in like so, and then my hot glue gun is already warmed up, so a little bit of hot glue here. I love the smell of hot glue in the morning, and then I'm just going to attach it a little bit further down just to make sure that it's going to make its way out and it's going to sit nicely. And if I just hold this here for a moment or two, that's the first of my modifications done. Easy. So that's my first of my modifications done. I'm going to be doing some work with this circuit board in a moment or two, but for just now I'm just going to set it aside. Because the next thing that I'm going to do is have a look at the rest of this case. I don't know if you can see inside, but this part of the case is a separate part to the top. And there seems to be some sort of tunnel inside here. This is where the sensors are going to go, and I'm guessing again this was for some sort of speaker to mount in at some point or another. But what I'm going to do with this is I'm just going to remove these 4 screws that you see here, and we'll have a look and see what this tunnel looks like inside, or this plastic assembly looks like. So here come the screws. And off we come. As you can see, there's a plastic tunnel down the middle here. You can see the grill, it fits in with just some clips. And then, if I can just get rid of some screws, the base here has got a reasonably flat thing. This is good news because if my NeoPixel light works, this should be reasonably solid enough for me to hot glue in my NeoPixel ring. So the next thing that we're going to do is we're just going to prepare the NeoPixel ring, which I've done in a separate bit of footage. I'll just splice these together, and then we'll give it a test using a microcontroller, and if it works okay, we'll then see about putting it into the device. So one of the things that I plan to do with my little Sonoff SC toy is hopefully to use it as a kind of notifier lamp or night lamp, or do something kind of fancy with it like that. So what I bought is I've bought this this ring. It's WS2812 LEDs, which are addressable RGB LEDs. A lot of people will call these NeoPixels, which is the name of the Adafruit product, which well, this isn't one of the Adafruit ones, but it's basically a clone that's come from eBay. So what I'm going to do with this to begin with is I'm just going to solder onto the back side of it. It has 4 ports. We've got a 5-volt grounds, DI, which is short for digital in, and DO, which is short for digital out. Now, in order to get a NeoPixel ring working, I actually don't need the digital out, so I'm only going to solder to the 5-volt ground and D in. I'm about to sell my house at the moment, so unfortunately all my good kit, which was in my workshop, I've had to put away for the moment, and it's in storage. So yeah, I'm going to be using an old house burner, my backup soldering iron, so this could get a little bit messy, but hopefully it won't be too bad. So let's just start off. I have these cables already. They were ones that I bought with the DuPont ends still already on them, and these are so cheap to buy from China that I buy them and cut them up to use for kind of connection cables for projects. So I'm going to start off by soldering the D in. I don't even have my helping hands here, so I'm just going to have to do my best with what I've got. So I'm going to start by laying a little bit of solder onto these pads, just to get the pads ready to accept some cables. So I've got a few dollops now, and if I just turn this sideways so that I can get my fingers into it. Here's my first one on. I'll go for the 5-volt now. And then the ground. Yeah, not the neatest job I've ever done, but it'll do for a start, and we'll just test it out in a second or two. Let me see if I can't just trim some of these loose ends away. I don't even have my nice trimmers with me. I've packed them away as well. Well, I don't think I'm going to be winning any awards for this particular soldering job, but I think it'll do. Now what I'm going to do is I'm just going to test this string out by plugging them in to a little Arduino development board here. So I'm just going to put, I'm going to D6 here, so I'm just going to pop the, probably better off switching this off just before I try this out. And there we can see, with a little bit of moving around of pins and things, I think I just had it plugged into the wrong pin on the board. This NeoPixel ring is working. I'm just running one of the Adafruit demos just now. Let me just see if I can't give it another. Oh yep, there we go. I don't know how much of this you can see in the camera. Let me just try. Switch this light off. Yeah, I think that's probably a little bit better. So now that I've got that running on here, what I'm going to try next is I'm going to try and put it into the shell of the Sonoff and just hopefully see if the Sonoff is going to transmit the light through it the way I think it's going to. So, wow. So as you can see, and as I'd hoped, the plastic casing of the Sonoff is translucent enough that it makes a very, very nice light show when we are shining the NeoPixel ring through it. So now that I know that it's going to work the way exactly I thought it was going to work, my next step is I'm going to glue this ring in place using some hot glue. So we'll see in a second what will happen with that. Okay then, so my test with my NeoPixel ring with using the other Arduino, that worked out really, really well. So what I'm going to do now is I'm just going to attach this NeoPixel ring to the device more permanently. For that we're going to use a little bit more hot glue. Before I start putting the hot glue in, I'm just going to feed these cables through the rather nice hole that they left here for us. And then we'll work out how we're going to attach these to the circuit board. I've used DuPont cables here, one because I want this top assembly to be detachable from the bottom assembly. I'm planning to maybe play around more with this. I've really bought it as a toy. So rather than have it all kind of permanently soldered together, I thought it'd be better if I could disconnect these easily. So before I do my gluing, I'm just going to feed these cables through the generously provided hole, and then we'll just see how this sits together. It's looking nice and easy here. So unfortunately the surface is a little bit rough. I was tempted to cut down with the Dremel some of these to make it sit a bit flatter, but what I think I'll do instead is I'm just going to be very generous with my hot glue, and I'm going to build up with the hot glue. So let's get this glued in place in a couple of different spots. We'll start with a nice big spot of hot glue just there, and let's hopefully just get this lined up before that hot glue grows cold. This is taking a while, just the glue is just really soft. I maybe shouldn't have put it in such a high heat, so I'm going to cool the thing down a little bit. It's starting to stiffen up a little bit now, which is a good time just to double check that everything's lined up nicely, and then we'll apply some more hot glue underneath. I'm not going to require a lot of glue here to get this together, because it shouldn't be under any sort of strain once the whole case is together. It really is just enough glue to hold it in place and no more. So I think one more scoosh should be enough. It's messy stuff, this hot glue, but the nice thing is if it goes in the wrong places compared to other glues, you can usually quite successfully remove it just by pulling away at the loose ends. So that's looking quite good. Let's just see how this all fits together now. Got a few strands of hot glue on this as well. There's a little kind of lug here which marries up with a lug there so that you know you're putting them on the right way around. And that's quite nice. That's already in place. So now that we've got it in place, what we're going to do now is just attach these screws. There we go. So that's my LED ring in place. What I think I'll do with it just now is I'm just going to give it a quick test before I do any more, just to make sure again that it's working properly, that I haven't dislodged any wires. So over here I've got a little Arduino development board, a Funduino, which is a great little unit, and I'm just going to plug this in. And hopefully, when I plug it in, there we go. I don't know if I can switch that off. And then again we can see it's just running through a demonstration just now, but it's looking pretty splendid. So that works just fine. I can set this aside for the moment, because what I want to do now is have a look at the board itself, and we're going to make a few changes to that. So here's the board itself. There's a couple of things that I'm going to do for starters. Number one is I have some headers here, so I'm going to apply some headers onto the programming headers. There's 1, 2, 3, 4, 5 of each, so I'm just going to find 1, 2, 3, 4, 5. I think I've miscounted there. 1, 2, 3, 4, 5, 6. So I'll just get rid of one of them, and we'll just solder them into place. So there's space in the base for the programming headers to sit there permanently. So I'm just going to pop these down quite quickly. This is where having all my tools to hand would be a better thing, but we can make do until we move house and we get my workshop back. So the first thing I'm going to do is I'm going to put one of these pins in place with the solder, and then just straighten it out And now that I've got that in place, I can then solder into place the rest of these headers. As you can see, we don't need anything particularly special soldering iron wise. I usually normally use a temperature controlled soldering iron, which is a little bit easier to use, but these what we sometimes affectionately call the house burners, the kind of fixed power soldering irons, they work more than well enough for what we're doing today. That's me got my programming headers in, so when I do get round to writing some code to control all of this, these are going to be very, very useful to me. The next thing that we're going to do, and I've pre-prepared this, if I can find whereabouts on my messy workbench I've left it, is I don't have enough space to put a header on these pins. These pins are the on the controller, but they're also connected to the SD card. So what I'm planning to do is I'm going to attach this little header to the terminals here, and I'm going to solder it on and then hot glue this onto my board here, like so, so that I can easily plug in the DuPont connectors from my LED light ring. There. Now that they're in place, I'm just going to move them around a little bit so that they're not going to interfere with that post hole there. And now that I've got a good location for them, we'll just put a dot of hot glue in. And now they're in place, we'll put a little bit more hot glue to tack that down. That's my alterations done to the hardware. All I really need to do now is to reassemble it. Anybody who has to do this, the tower that these sensors sit on is held on with a couple of bolts. The temptation would be to tighten these bolts up because it's currently loose. The problem you have is that if you do tighten those bolts up, you'll find that the entire assembly won't make its way into place. I'll pull these cables back for the moment. We will work out which way around this goes, which is with the little push button to the back of the unit. We kind of squeeze the unit together and then tilt, and in it goes. I've left my 3 cables just sitting out just now. Then we'll put these 4 screws in place. And then it's just a matter of connecting my connectors, my DuPont connectors, which go 1, 2, and 3. And if I just tuck these cables away, they should sit just nicely. And that's my modifications complete. The last thing that I'm going to do is I will program this microcontroller using a serial to USB connector, and then we'll just see if it works. Okay, so what I've done is after assembling back the unit, I've just got myself one of these. This is a little USB to serial. It's an FTDI chip, or at least it claims to be. This is one of the ones which is 3.3 volt or 5 volt selectable. A really useful tool for your toolbox. I've got it set for 5 volts because the APP Mega controller is going to be running at 5 volts. And I'll just let you see how we're going to program this. The controller has got several different pins. It's got ground, which naturally we attach to ground on our Sonoff PCB. We have VCC, which is the voltage. So I've got that attached to the 5 volt connector. I don't know if you can see the connectors here. They are labelled on the device. We've then got TX and RX. Now normally when you are connecting to a microcontroller using one of these serial adapters, TX on the adapter would go to RX on the device, and RX on the device would go to TX on the adapter. But the way they've labelled it on the Sonoff board here, they've actually labelled it back to front. So in this case, TX goes to TX and RX goes to RX. The last pin that I've connected is DTR. DTR is going to send a signal which is going to reset my microcontroller. This just puts the microcontroller into bootloader mode when the Arduino environment downloads it. So the sketch that I am about to download is from Adafruit. It's using their NeoPixel library, yeah, the only thing that I really needed to change was I had to tell it in the sample sketch that there were 24 LEDs, and I also had to tell it in the sample sketch that the pin that I'm attached to here, this is pin number 11 on the as far as the Arduino environment is concerned. This is attached to the in-circuit serial programmer, which is also attached to pin 11. So I'm going to update these. There will be a bit of flashing around, and after a second or two, hey presto, we have a working unit. So that's the as far as I'm going to go today. Obviously I've got a little bit of work ahead of me now. There are 1 or 2 people working on homebrew software for these Sonoff SC devices. So I'm currently not sure whether I'm going to program something completely from scratch for my own purposes, because nobody's doing the light ring yet, or whether or not I will take one of the projects that someone's already got working and then just maybe modify their code to add the LED light notification as well.